Okay. So in amines, please write first of all reduction of nitro compounds. पहले method of preparation लिख लीजिए. We are going to talk about the method of preparation of amines. Right, the first method of preparation, reduction of nitro compounds. ठीक है, reduction of nitro compounds. Now you can do reduction of nitro compounds. अच्छा, अभी बच्चे आ रहे हैं. I'll wait 2 more minutes. Let the students know. Okay, those who have come just now, please write this down. Amines, method of preparation, the first method of preparation, reduction of nitro compounds. In reduction of nitro compounds, please write. You have RNO2. It can be alkyl, nitroalkane, or nitroarene also. Okay, so you can have benzene rings also. You have RNO2. It can be reduced using 3 different reagents. The first reagent is H2, the presence of PD, nickel or something else. Platinum, palladium, and nickel. Nickel, platinum, and palladium. These are the 3 catalysts. These are the 3 metals that can be used, and you can get RNH2. That is amine. Similarly, Fe plus HCl can be used, and you will get RNH2. Then you have Sn plus HCl. You'll get RNH2. Fe plus HCl is the preferred method. Please write here. This is the preferred method. Why it is preferred method? Because if you have Fe plus HCl, one of the byproduct will be FeCl2, and FeCl2 can be easily hydrolyzed with water, and FeCl2 will in turn give HCl. So starting you need to use very little HCl, because whatever byproduct you are getting, this will be reconverted to HCl. Okay, so please write here. Note. A reduction of RNO2 with Fe plus HCl is preferred as it forms FeCl2. Which can be easily hydrolyzed, and form HCl. Which can be used back as reagent. Therefore, very little amount of HCl is required. Right, next, monolysis of alkaline, second method of preparation. जैसे hydrolysis होता है ना, hydrolysis is what? Addition of water. Monolysis is addition of NH3. Okay, so we'll put NH3 and that will be a monolysis. Okay, a monolysis of alkyl halide. Now this reaction we have seen already slightly in haloalkane halorine chapter. You take ammonia and any haloalkane. Now this haloalkane will be delta positive because it is attached with electronegative element halogen. And this nitrogen is going to attach onto this R group here. And we are going to get R that is attached with NH3. And this is going to leave also. Now nitrogen will have a positive charge and the halogen will have negative charge. Now further reaction with any base such as NaOH, you will get RNH2. Okay, so RNH2 क्या है हमारे पास? This is my 1 degree amine. Now please see this 1 degree amine RNH2. Okay. Now this nitrogen, it still has some lone pair electron. And if it finds any haloalkane once again, because ऐसा नहीं है ना कि सारे के सारे haloalkane they will react at a time only. All will be consumed at one time. एक second हुआ सारे के सारे consumed. No. There will be some haloalkane which will be unreacted still once this 1 degree is formed. So it will again attack onto this. This nitrogen atom will again attack. And what we are going to get? We are going to get 2 R groups attached on the nitrogen atom. And you will have 1 hydrogen. But still this lone pair electron is there. So this can again react with the haloalkane and it can get 3 alkyl groups on the nitrogen. But it still has a lone pair electron. So it will again react to get a quaternary ammonium salt. So now once it gets the positive charge, it does not have any lone pair electron now. It does not have lone pair electron now, then it will not react with RX. So this is known as quaternary ammonium salt. Okay, quaternary ammonium salt. Now this quaternary ammonium salt, this don't react further on. But this is a problem, right? This is a problem because we are going to get a mixture of 1 degree, 2 degree, 3 degree and quaternary ammonium salts. If I do monolysis of alkaline, right? Why? Some of the 1 degree, they won't find any haloalkane. तो ऐसे ही रहेगा. But there will be some amines, 1 degree amines that will find haloalkane. They will become 2 degree. Some of the 2 degree will not find any other haloalkane, so they will remain 2 degree. But some of the 2 degree will find haloalkane, they will become 3 degree. Similarly, some 3 degree will also become quaternary ammonium salt. So what we will be getting? We will be getting a khichdi. That is, we are going to get 1 degree, 2 degree, 3 degree, all kind of amines. And to separate these things, it is very difficult because they will have similar boiling point, melting point because their molar masses will be also similar. So this is not a preferred method of preparation of amines. Okay? So please write no. This is not a preferred method of preparation for amines as it gives mixture of 1 degree, 2 degree, 3 degree and quaternary ammonium salt. Okay, now if we want primary amine to be the major product, okay, so we will always get a mixture, but if you want the primary amine to be major product, then we should have a high amount of ammonia कि ammonia ही react करे haloalkane से 1 degree amine ना react कर पाए. Okay, so do that. What we will need, please write, to get 1 degree amine as major product, NH3 should be in excess. Now, what about haloalkanes, whose reactivity is the most? So please write order of reactivity of haloalkane. So here, alkyl halide makes say alkyl iodide is the fastest because Ri bond is very weak. It will break easily. Then we have RBr and then we have RCl. So RCl is the slowest. Fastest is alkyl iodide. Write this down. After this, write the third method of preparation. Reduction of nitriles.
Sir, can you say the notes?
Yeah,
The
just a
note.
second. हाँ एक सेकंड निकलने दीजिए जी. Let me know when you are done, Akshay. Done? आगे बढ़े?
Yes, sir.
Okay. No. Reduction of nitriles. So we will use reducing agent. So please write. We can use 3 reducing agent: lithium aluminium hydride, or we can use H2 in the presence of nickel. इसको ना रानी निकल भी बोल देते कभी. RANEY nickel. And the third is sodium amalgam in the presence of ethanol. So if you have R, C triple bond N, H2 in the presence of nickel, you will get R. Both carbon and nitrogen will get 2 hydrogens, that is CH2 and NH2. Okay. Now you can also convert benzene nitrile and you will get CH2, NH2. Now, since you have nitrile, you can be asked questions like, जैसे ही नाइट्राइल मिला ना तो आप प्लीज केसीएन वाला रिएक्शन जरूर याद रखा कीजिए जब भी आपको नाइट्राइल मिले. So if you have ethanol and you want to convert ethanol to propane nitrile, that means we have 2 carbon atoms here and we want to convert this to 3 carbon atoms. Right? 1, 2, 3 carbon atoms and then NH2. So what we can do, first of all, haloalkane, SOCl2, this will convert to Cl. Then I will convert this to nitrile, KCN. And once I got nitrile, I will just add LiAlH4. I will get NH2. Please write this down. The ascent of carbon atoms, 1 carbon ज़्यादा. Okay, moving on. Write the fourth method of preparation. Reduction of amides. You have simple RC double bond O NH2. You react this with LiAlH4. And then add water. You will get R CH2 NH2. ठीक है? सिर्फ सीधा सीधा पानी डाल दीजिएगा अगर. If you just add water, then you will get carboxylic acid. You reduce it and then add water, you will get amides. You will get amines from amides. Right, the fifth reaction, this is important. Gabriel-Thalamide synthesis. If you remember thalamide from carboxylic acid, the chemical properties of carboxylic acid, you have benzene ring and one another 5-membered ring of nitrogen with double bond O here, double bond O here, and a hydrogen here. Now this hydrogen here, it is quite acidic because if I remove the hydrogen from here, the negative charge of nitrogen will be in resonance with this oxygen also and this oxygen also. Further, it will be resonance with the benzene ring. So it will be a very stable conjugate base, and hence we can react this with KOH. Once we react this with KOH, we will get the benzene ring as it is, nitrogen, and nitrogen will have, wait a second, this double bond O as it is, nitrogen will have negative charge and there will be K positive. So this will be potassium with a potassium salt of thalamide. And then we will react with alkyl halide. अब यहाँ पे यही होगा, delta positive because it is a connected to electronegative element. This nitrogen is going to attack on this R group, this is going to leave, and then K plus and X negative will be there. So you will get a benzene ring, nitrogen, double bond, and R group here. Okay, this is known as N-alkyl thalamide. This is known as N-alkyl thalamide. Now, once we have got this, we will treat this with NaOH. So, this will become COO negative. There will be Na positive here and Na positive here. This N will get the two hydrogens and you will get R NH2, 1 degree amine. So why is Gabriel thalamide synthesis used? It is used for preparation of 1 degree amine. Right, next. Thalamide on treatment with KOH. Forms potassium salt of thalamide. Salt of thalamide, which on treatment with haloalkane forms N-alkyl thalamide. अगर आप क्लोरोमीथेन से कर रहे हैं, मिथाइल फ्लोराइड से कर रहे हैं, मिथाइल ब्रोमाइड से, इथाइल फ्लोराइड से, so whatever R group you are using here, this complete R group will be attached, है ना? अच्छा, एक और चीज इंपॉर्टेंट है, जो ये जो रिएक्शन है आपका, दिस इज SN, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन, ओके, दिस इज इंपॉर्टेंट, इसके बारे में बताएंगे क्यों. विथ हालो अल्काइन लिख दिया हमने, विथ हालो अल्केन लिख दीजिए प्लीज. विथ हालो अल्केन forms an alkyl halimide via SN, and on further hydrolysis it forms 1 degree amine. It forms 1 degree amine. Write a note. This method cannot be used for preparation of aromatic amines, as aryl halides do not show SN, है ना? So we have, if you are going to get aromatic amines, then you will use aryl halide, aromatic halides also. But aromatic halides, they don't show SN. If they don't show SN, then how can this reaction take place? Okay. So that is why we cannot prepare aryl halides with this. We cannot prepare aniline from this. We can only prepare aliphatic 1 degree amines. Right, next, another important reaction is Hoffman bromamide degradation. ये कौन सा sixth हो जाएगा ये? Yeah, this will be sixth. Please write. Hoffman bromamide degradation. Okay, in this we use amide R C double bond O NH2, plus we use Br2, plus we use KOH. ठीक है, ये ध्यान रखिएगा, Br2 plus KOH जो आपको देगा ना, this is going to give you सोडियम पोटेशियम हाइपोहालाइड. हाइपोहालाइड कैसा होगा? KOBr, या फिर if you are going to use NaOH, you will get NaOBr. So even if you have NaOBr ना, तब भी आप यही रिएक्शन कीजिएगा प्लीज, ठीक है? Because NaOBr कहाँ से आ रहा है? Br2 plus KOH से ही आ रहा है. Okay, so you will get here RNH2. ठीक है, ये कार्बोनिल ग्रुप जो है ना उड़ जाएगा. Okay, so this is degradation. Degradation मतलब you will be having the product that is going to be formed will have 1 carbon less than the amide, है ना? That is why it is degradation. कार्बन का 1 नंबर का descent. Plus you will get K2CO3, plus you will get KBr, and you will get H2O. ठीक है? Now, in Hoffman bromide degradation, why it is used? Please write. used for preparation of 1-degree amine. Reagents: Br2 plus KOH और हाइपोहैलाइट लिख दें या फिर हम ऐसे लिख देते हैं NaOBr लिख लीजिए आप, ठीक है ना, तो ध्यान रहेगा आपको. That is formed by Br2 plus KOH. Right, next, the amine form has one carbon less than the amide. Sorry, I'll directly get NH2. No, these type of reactions are important if you have a conversion like this. You have to go from propanol to ethanamine. That means we have to go from 1 to 3 carbon atoms OH to 1 2 carbon atoms and NH2. So whenever you have one carbon less, Hoffman bromide degradation कहीं आप लोग लिख जरूर आइएगा. Okay, it will be somewhere here. So please see. First, I will react this with SOCl2. SOCl2. नहीं, एक काम करते हैं. We will react this with KMnO4. And then we will get carboxylic acid. After carboxylic acid, after we have got carboxylic acid, we'll react with this ammonia, and then we'll heat it. Ammonia से react कराएंगे तो we will first of all get salt, है ना, carboxylic acid का reaction है. And after we heat it, water will be removed, and you will get CONH2. And then for this, you just need what? NaOBr or KOBr or NaOBr. That's it. Right, next, physical properties. चलिए देखिए, amines except 3-degree amines, ठीक है, 1 and 2-degree amines दोनों में can form hydrogen bond, and hence they have higher boiling point than corresponding hydrocarbons and polar molecules. But boiling point of amines is lower than that of alcohol. ठीक है, फर्स्ट पॉइंट तो आई थिंक एक्सप्लेन करने की जरूरत नहीं है, बिकॉज आपके पास क्या होता है, आर नाइट्रोजन, और अगर आपके पास दोनों तरफ हाइड्रोजन है तो फिर आपके पास बन रहा है, इवन अगर आपके पास एक तरफ हाइड्रोजन है तब भी आपके पास हाइड्रोजन बॉन्ड बन रहा है. बट इफ यू हैव 3 alkyl groups, that means this is 3 degree amine, and in this 3 degree amine we are not going to get any hydrogen bond because hydrogen is not connected to nitrogen, which is electronegative element. Now boiling point of amine is lower than that of alcohol. Why? Alcohol may be hydrogen bond, may be hydrogen bond, but why is the boiling point of amines less than alcohol? It is because alcohol has a hydrogen bond with, due to OH, this oxygen is highly electronegative. It creates a high delta positive charge, और यहाँ पे जो फिर ऑक्सीजन होता है वो उसी तरह से जितना ज्यादा पॉजिटिव चार्ज और यहाँ पे डेल्टा नेगेटिव चार्ज उतना ही ज्यादा. एंड इफ यू हैव पॉजिटिव एंड नेगेटिव इंटरेक्शन, इलेक्ट्रोस्टैटिक्स आपने पढ़ा होगा, यहाँ पे पॉजिटिव यहाँ पे नेगेटिव ज्यादा, सो force of attraction is also greater. Okay, so due to the high electronegativity of oxygen atom, the hydrogen bond formed by alcohol is going to be more strong. Okay, so please write lower than that of alcohol because the hydrogen bond of alcohol. तो अल्कोहल के साथ ना यहाँ पे कार्बन, सॉरी एक सेकंड, Ca भी लिख लीजिए यहाँ पे, कार्बोक्सिलिक एसिड. ओके, बिकॉज द हाइड्रोजन बॉन्ड ऑफ अल्कोहल एंड कार्बोक्सिलिक एसिड is formed by more electronegative oxygen atom. Now, if I talk about amines, amines में सबसे ज्यादा boiling point किसका होगा? तो highest boiling point will be with 1 degree amine, then 2 degree, and then 3 degree. Okay, so please write. Since 1 degree amine has 2 hydrogen per molecule, it can form more hydrogen bonds, therefore has high boiling point than 2 degree amine. High boiling point than 2 degree amine. ठीक है, तो सबसे ज्यादा किसका? RNH2, फिर उसके बाद R2NH, उसके बाद R3N, 1 degree, 2 degree, 3 degree. Now let's talk about the solubility. Please write. Amines are soluble in water as they can form hydrogen bond with water. Amines are soluble in water as they can form hydrogen bond with water. As they can form hydrogen bond with water, but the solubility decreases as the number of carbon atom increases in alkyl chain. Also write next point. Amines are less soluble than alcohol. Amines are less soluble than alcohol in water. due to lower electronegativity of nitrogen atom. ठीक है, तो ये तो पढ़ के आप लोग बोर हो चुके होंगे। अभी तो फिजिकल प्रॉपर्टीज है ना, हाइड्रोजन बॉन्ड है तो ज्यादा होगा बॉइलिंग पॉइंट, हाइड्रोजन बॉन्ड नहीं है तो कम होगा बॉइलिंग पॉइंट, पानी में सॉल्युबल होगा अगर वो हाइड्रोजन बॉन्ड पानी के साथ बना लेता होगा। ओके, सो दीज आर द सेम थिंग्स। कंप्लीट दिस थिंग and then write chemical properties. Chemical properties में write the first topic, basic character. Now, like the acidic character of carboxylic acid, we will also learn this basic character in 3 different parts. Reaction, basic strength कैसे देखेंगे, और उसके बाद effect of substituent. Please write the first one. Reaction with hydrogen halide, HX. So I have RNH3. Sorry, RNH2 will be there, not NH3. With a lone pair electron and hydrogen. This HX will have delta positive here, delta negative here. This nitrogen atom is going to attack onto this hydrogen atom, and we will get RNH3. Nitrogen will get positive charge because it donated electron, and you will get X negative. Okay, you'll get X negative. Similarly, if you have aniline, react this with HBr. Get NH3 positive and Br negative. ठीक है, so why are amines behaving as a base? H को abstract कर ले रहे हैं, हाइड्रोजन को abstract कर ले रहे हैं, तो ये किसकी तरह behave कर रहे हैं? These are behaving as lowest base because they are not giving OH negative. What they are doing? They are donating electron and abstracting, and it is abstracting the H plus ion. That is why it is lowest base. Please write. Amines have lone pair electron on nitrogen. Due to which they behave as lowest base. Due to which they behave as lowest base. B में लिखिए आप लोग, रिएक्शन हो गया, बेसिक स्ट्रेंथ. बेसिक स्ट्रेंथ लिखते हैं. We calculate the basic strength RNH2 and we add this to water. So water will be HOH hoga. This will be H positive. Nitrogen can attack and it will give you R NH3 positive, and you will also get OH negative. Now same things. The equilibrium constant K will be equal to the concentration of product upon the concentration of a reactant. Now in product we have R NH3 positive and OH negative divided by R NH2 and H2O. Now since water is what Water is a pure liquid. Its concentration is not going to change. We'll multiply K into the concentration of H2O. This is now your Kb. This will be equal to the concentration of RNH3 positive into the concentration of OH negative divided by RNH2. Okay. So obvious सी बात है, यहाँ पे आप अगर आप देखें, so if you have too much OH negative, that means the product की quantity ज़्यादा है, Kb भी ज़्यादा होगा. That is why if Kb is high, we can say that strong base. But again, we don't use Kb, we use pKb, and pKb is equal to minus log of Kb. Minus log of Kb, it means if the Kb is high, if the Kb is high, this complete thing will be low because negative sign. pKb is going to be low. Therefore, strong base has lower pKb value. It has lower pKb value. Okay. This is about basic strength. Now we will talk about the effect of substituent. Please write.
So can you scroll up?
Yeah, sure. Those who are done, they can write C. Effect of substituent.
Done.
Effect of substituent. Now we'll compare here. If I have ammonia, ठीक है? So ammonia हो चाहे आपके पास यहाँ पे amines हो, all of these are what? All of these are base because they have a lone pair electron on the nitrogen atom. You have one R group, nitrogen, and two hydrogens. You have two R groups, one hydrogen. Or if you have three R groups attached to nitrogen atom. ठीक है, तो ammonia हो गया, this will be 1 degree, this will be 2 degree, this will be 3 degree. अच्छा. Now, all of these are based on electron density on nitrogen atom. ठीक है, ध्यान से सुनिएगा guys. Please अगर लिख रहे हैं तो मत लिखिए. Please listen very carefully. All the amines are basic in nature because they have high electron density at nitrogen atom. Now tell me, if I increase the electron density at nitrogen atom, what I am doing, guys? Tell me what I am doing. I am increasing the electron density at. I am increasing the electron density at what?
Nitrogen.
Nitrogen. What we are doing? Can you please repeat it? If I
Increase the electron density at nitrogen.
Thank you, sir. If I increase the electron density on nitrogen atom, so nitrogen को donate करने में आसानी हो जाएगी, right? Nitrogen is donating the electron, and that is why it is basic. If I give it more electrons, it will be easier for the nitrogen to donate. Is that clear? Yes or no? Please tell me, guys. सही है?
Yes, sir.
Yes.
Now, if I look, now this is known as electronics. So क्या बोलते हैं? Okay, so generally आपके level में आप electronics के हिसाब से on the basis of electronics, like where are the electrons, उसके basis पे आप आंसर कर सकते हैं चीजों को, ठीक है? But sometimes things get complicated. For example, यहाँ पे देखिए अगर electronics की अगर हम बात करें, so alkyl group is electron donating group, so there we have one alkyl group here, so it will donate electron. This will donate electron, and in the 2 degree 2 alkyl group will donate electron. In 3 degree 3 alkyl group will donate the electron. Now, considering the electronics, tell me which nitrogen is going to have the highest electron density? Ammonia 1 degree, 2 degree, or 3 degree? किसके पास सबसे ज्यादा electron density होगा? 3 degree के पास. Now, if 3 degree has the highest electron density, then according to the electronics, this should be most basic. Yes or no? Please tell me, guys. सही है?
Yes. Yes.
3 degree, 2 degree, and 1 degree according to the electronics, and then you will have ammonia. But अब आप ये सोचिए, हम आर्क हटा रहे हैं एंड हम एक स्पेसिफिक ग्रुप लेते हैं, ठीक है ना? लेट अस टेक CH3 in our hands. Let us take CH3. So CH3 will have one carbon atom, which will also have 3 hydrogens. Here you will have 2 carbon atoms, and both of them will have 3 hydrogens. Here you will have 3 carbon atoms. ठीक है? You'll have 3 carbon atoms, and all of them will have hydrogen atoms. And एक चीज ध्यान रखिएगा आप लोग, all the chemical reaction, whether it is acid base, अगर ये electrons है ना, तो this electron has to move and give to the electron poor species. Electron source to electron sinks, electron rich to electron poor. So electrons move. अब ये देख के बताइए, आप साइज देख के बताइए, which will be easiest to move? इसको बोलते हैं steric. Steric effects जो होता है इसको बोलते हैं sterics. Now according to the sterics, tell me, इन सब में से सबसे आसानी से कौन मूव कर सकता है? अमोनिया 1 डिग्री, 2 डिग्री और 3 डिग्री. Look at the size and tell me who is the most feasible to donate electrons. सबसे आसानी से donate कौन कर सकता है? Like for example, अगर आपके पास कुछ H plus ion आया, या फिर if you have CH3 plus, if anything is there that is having a positive charge, which will be the most effective, which can donate easily? बहुत आसानी से कौन donate कर सकता है? Movement के हिसाब से बताइए. According to the movement, tell me guys.
1 degree.
Yes, Krishna.
So 1 degree.
नहीं, 1 डिग्री से भी ज्यादा अमोनिया है ना?
Yes. Yes.
सही है? NH3 1 degree, 2 degree and 3 degree. This is again the order of basic strength according to the sterics. Now, all of you agree with this 2 points? Yes or no? Please tell me the electronics and the sterics. Clear है?
Yes, sir.
Yes.
But both of them are giving us conflicting result. Yes or no? ये भी सही है. Correct. Both of these are giving us conflicting results, na?
Yes, sir.
Correct. So for this, what we are going to do, we are going to base our conclusion on the basic strength on experimental results. Okay, so please write. Since basicity is determined by multiple factors, with conflicting results, we will conclude with experimental results. ठीक है, अब जो रिजल्ट लिखेंगे वो इंपॉर्टेंट. प्लीज राइट दिस डाउन, लेट मी नो once you're done. Then guys, can we move on? हाँ, लिख ले सबने?
Yes, sir.
Yes,
Yes, sir.
please write. If you have methyl substituent, क्या है हमारे पास अगर if we have methyl substituent, then 2 degree will have the, because वो optimize हो गया ना, उसमें electron density भी ज्यादा है, वो बहुत ज्यादा पड़ा, 2 degree, then 1 degree and then 3 degree. ठीक है, 2 degree, 1 degree and then 3 degree, and after that you will have ammonia. That means if I write the specific molecules, हम कहना ये चाह रहे हैं CH3 whole twice NH 2 degree amine, और सब्स्टिट्यूएंट क्या है यहाँ पे, मिथाइल है. ठीक है, ये CH3 2 बार है तो मिथाइल है, इथाइल नहीं है, ये 2 कार्बन मत ले लीजिएगा इसको. ठीक है, दिस इज CH3 whole twice मिथाइल है. Then you can have CH3 NH2 एक मिथाइल तो 1 degree, then CH3 whole thrice nitrogen and then ammonia NH3. But if I have ethyl substituent, then in that case 2 degree, 3 degree, 1 degree and then ammonia. That means C2H5, this is ethyl, twice 2 degree NH, C2H5 whole thrice nitrogen. At last we'll have C2H5 NH2 and then NH3. Right, next.
Sir, can you scroll up?
कनेक्ट था आपने, निकली जल्दी क्या?
Done, sir.
Right here. Aryl amines are less basic than amines because the lone pair electron of NH2 in aniline is in resonance and less available. ठीक है, इट इज डीलोकलाइज्ड, एक जगह रहेगा इलेक्ट्रॉन तभी तो वो किसी को डोनेट कर सकता है, और दैट लोन पे इलेक्ट्रॉन इज कंप्लीटली डीलोकलाइज्ड, वो एक जगह है ही नहीं, एंड दैट इज व्हाई इट इज लेस बेसिक. ठीक है, दैट नॉर्मल amines. You can also write that is pH group is electron withdrawing group. ठीक है, फिनाइल ग्रुप क्या होता है, इलेक्ट्रॉन विड्रॉइंग ग्रुप, बिकॉज आप देख सकते हैं देखिए इलेक्ट्रॉन कौन ले रहा है, किसकी तरफ जा रहा है इलेक्ट्रॉन, फिनाइल की तरफ जा रहा है, फिनाइल खींच ले रहा है इलेक्ट्रॉन, राइट. सो फिनाइल ग्रुप इज व्हाट, इट इज इलेक्ट्रॉन विड्रॉइंग ग्रुप. NH2 के हिसाब से कर देखिए तो आप फिनाइल क्या कर रहा है, इलेक्ट्रॉन खींच ले रहा है नाइट्रोजन से. नाउ राइट, नेक्स्ट अराइल अमीन वर्सेस अमोनिया. aryl amine versus ammonia. Wrote these 3 lines, 4 lines. Aryl amines are less basic than amines because the lone pair
Yes,
electron of aniline is in resonance and less available. That is pH group is electron withdrawing group. Done. चलिए अब यहाँ पे देखिए. Now aryl amine को देखते हैं. ठीक है. It will give you H plus ion. It will become NH3 positive. ठीक है. ध्यान से सुनिए. This aniline it has 5 resonating structure. इसका resonating structure देखना है. OH का resonating structure देखिए 5 resonating structures होंगे. यहाँ से आप आगे बना सकते हैं इस तरह से. एक बार इलेक्ट्रॉन यहाँ पे आ जाएगा, एक बार इलेक्ट्रॉन यहाँ पे आ जाएगा, एक बार इलेक्ट्रॉन यहाँ पे आ जाएगा. तो एक अभी है. ठीक है. अब उसके बाद 3 इस तरह के बनेंगे जहाँ पे चार्जेस होगा और एक लास्ट बनेगा जहाँ पे फिर से न्यूट्रल हो जाएगा. Okay, so 3 will have charge and 2 will be neutrals. So you will get 5 resonating structures for aniline. इसके लिए aniline के लिए. But what about this particular anilinium ion? This is anilinium ion. आप बोलेंगे सर ये यहाँ पे ऐसे बना सकता है. TC बहुत सारे लोग ऐसे लिख सकते हैं, बट आप मत लिखिए अभी. ठीक है ना. I will tell you what is the problem here. Double bond NH3 नेगेटिव चार्ज पॉजिटिव चार्ज तो चला गया, यहाँ पे पॉजिटिव चार्ज आ जाएगा लाइक दिस. अब इस नाइट्रोजन को अगर आप देखिएगा, दिस नाइट्रोजन इज हैविंग 5 बॉन्ड्स नाउ, व्हिच इज इम्पॉसिबल बिकॉज़ नाइट्रोजन इज अ पीरियड सेकंड ग्रुप एलिमेंट. ठीक है. नाइट्रोजन इज द सेकंड. That is why anilinium ion cannot have resonance like this. It can have only one resonance, which is between the double bonds of benzene ring. सिर्फ कार्बन कार्बन के बीच में यहाँ पे होगा. We'll have double bond here, and double bond here. So this is a only one type of resonance it can show, and you will have still NH3 positive. Now this anilinium ion has 2 resonating structure. It has 2 resonating structure. Aniline has 5 resonating structure. Aniline के पास कितने हैं? Aniline के पास 5 resonating structure है. That is 3 more. वही चार्ज वाले जो हम बता रहे थे ना, that is 3 more resonating structure. So obviously, which is more stable? Aniline is more stable or anilinium is more stable? Guys, tell me, which is more stable? Aniline or anilinium?
aniline.
Aniline is more stable. अब अगर aniline is more stable, तो वो तो खुद नहीं चाहेगा ना रिएक्ट करने के लिए. It will not want to take the H plus ion. ठीक है. So that is one reason. एक reason क्या है? Another reason that aryl amine is less basic than ammonia. एक reason तो ये है कि aryl amines are not ready to get converted to anilinium ion because anilinium ion is less stable than aniline. One more reason is that we have already seen the phenyl group that is attached to NH2, the phenyl group that is attached to NH2, that is an electron withdrawing group. There is no such electron withdrawing group present at ammonia. ठीक है. There is no such electron withdrawing group that is present in ammonia. So these are the 2 reasons why we can say aryl amines is less basic than ammonia. Aryl amines are less basic than ammonia. Please write. First of all, pH group phenyl group है ना, ये बेंजीन रिंग को phenyl group बोलते हैं. Yes, electron withdrawing group and but ammonia does not have such electron withdrawing group. Second point, aniline has more resonating structures than anilinium ion. Hence, it is difficult Okay, hence it is difficult to form aniline amine. तीसरा पॉइंट लिख लीजिए. Also, the lone pair electron of aniline is delocalized and less available. But या फिर whereas लिख लीजिए. Whereas the lone pair of ammonia is localized. Therefore, ammonia is more basic than amine. ठीक है. तो जनरल जो आपके पास ऑर्डर आएगा 2 डिग्री सबसे ज्यादा, उसके बाद 1 डिग्री या 3 डिग्री, तो उसके लिए हम एलिफैटिक लिख दे रहे हैं. उसके बाद आएगा आपके पास अमोनिया एंड अंत में आएगा अराइल अमीन. अराइल अमीन विल बी एट द एंड. सवाल लिखिएगा एक. कंपेयर द बेसिक स्ट्रेंथ ऑफ फॉलोइंग. ऐसा लिखिए, कंपेयर pKb values for following. C6H5NH2, C2H5NH2, C2H5 volt twice NH, at last we have NH3. सबसे पहले ना क्लासिफाई कर लीजिए कौन, अगर 2 डिग्री है तो सबसे पहले 2 डिग्री सबसे ज्यादा बेसिक, उसके बाद 1 डिग्री और 3 डिग्री अगर मौजूद है तो फिर आप देखिए. ठीक है. तो प्लीज सी कि मिथाइल है या इथाइल है, उसके अलावा कुछ और केस आपको देंगे नहीं. ठीक है. और अगर 2 डिग्री 1 डिग्री 3 डिग्री नहीं है, कोई एक ही है, एंड देन यू हैव अमोनिया एंड अराइल, तो फिर उसके बाद आप किसको दीजिएगा? 1 डिग्री, देन यू विल गेट टू अमोनिया एंड देन यू विल गेट टू अराइल अमीन. ठीक है. पहले क्लासिफाई कर लीजिए कि ये जो मॉलिक्यूल है अराइल अमीन है या फिर 1 डिग्री है, 2 डिग्री है, 3 डिग्री या फिर अमोनिया है, क्या है ये. ठीक है. अब उसके बाद लिखिएगा एसिडिक स्ट्रेंथ का, कंपेयर कीजिए एसिडिक स्ट्रेंथ, एंड देन उसके अपोजिट आपका पीकेबी वैल्यूज हो जाएगा. पहले एसिडिक स्ट्रेंथ कीजिएगा. ठीक है. डायरेक्ट पीकेबी वैल्यूज मत करने बैठिएगा. This will be A, B, C, D. अच्छा किसी ने आंसर भेजा है? Yeah. Correct. Very good. Very good. Krishna. सही है बिल्कुल. If you are going to send the answer, please send the answers now. ये आपके पास अराइल अमीन हो जाएगा. ये 1 डिग्री, ये 2 डिग्री और ये अमोनिया. ठीक है. So if I talk about the acidic strength, basic strength, acidic strength बोल रहे थे क्या? मतलब जैसे basic strength guys, basic strength. Okay, my bad. Basic strength C, B, D, A. ठीक है. और अगर हम P के B वैल्यू की बात करें तो C, B, D, A. क्या गलती कर दिया आपने अक्षय?
Yes, so can you explain the C?
सॉरी,
How you got C, B, D, A?
सबसे ज्यादा 2 डिग्री.
Yes.
तो 2 डिग्री, उसके बाद 1 डिग्री है ना. उसके बाद अमोनिया. देखिए.
Yes. Okay, okay. I mean, yes, okay. Understood.
ठीक है. Right. Second reaction. Alkylation. You have just seen alkylation by the way, है ना. क्या होता है? You have 1 degree amine. You react this with any haloalkane, so it will give the alkyl group to nitrogen. तो उसी को बोलते हैं alkylation. Okay, so you will get R, nitrogen, again R. There will be 2 hydrogens here with nitrogen में positive charge, and in the presence of a base, वो एक हाइड्रोजन को लेके चला जाएगा, हाइड्रोजन इलेक्ट्रॉन दे देगा नाइट्रोजन को. You will get R, N, R and H. ठीक है. फर्दर ये रिएक्ट कर जाएगा किससे? अच्छा एक काम करते हैं, इसको R डैश कर देते हैं. दिस इज R डैश, अगेन R डैश X. तो आपको मिल जाएगा R, N, R dash and one more R dash. Okay, so please write 1 degree amines and 2 degree amines. 1 degree and 2 degree amines. React with alkalinide to form 3 degree amines. To form 3 degree amines. देखिए एक एग्जांपल देखिए. We have CH2NH2, CH3NH2. We have CH3NH2. We react this with, we have methane amine. We will react this with ethane amine. CH3, CH2, NH. CH3, CH2. Methyl. We have methane amine. We will react this with bromoethane. Okay, ethyl bromide. So this carbon atom here, it will attack on this carbon atom. This nitrogen atom here, it will attack here. और आपको क्या मिल जाएगा? CH3. We will have nitrogen, which has 1 hydrogen and 2 carbon groups like this. So we have got first product. ये 2 degree हो गया. It will again react this ethyl bromide and we will get CH3, nitrogen, 2 carbon groups here and 2 carbon groups here. This is 3 degree. Now the thing that I want to tell you guys here is how to name this particular molecule. Okay, इस molecule को name करने के लिए भी we have the same rules applied here. We have the functional group, identify the functional group, unsaturation, parent, and then the substituent. Now, since we have nitrogen atom that is attached with alkyl groups here, nitrogen atom attached to carbon atom, the functional group is obviously going to be amine. Functional group क्या होने वाला है? Functional group is going to be amine. If you see nitrogen attached to carbon atom and there is no carbonyl orbital group, so फिर उसके बाद amine. Unsaturation is obviously AN because we don't see any double bond or triple bond. Now, what about the parent? We know that the parent should have, it should include the parent chain should include the functional group. If you can see the alkyl groups that are connected, all of them, 3 of them are connected to the nitrogen. So all of them are connected to the functional group. Okay. So now what is the deciding factor? Longest chain. So you can see that longest chain is with ethyl. Okay. But you will stop at nitrogen. ठीक है ना? आप यहाँ से ऐसे पूरा मत कर लीजिएगा because बीच में nitrogen नहीं आ सकता. It should be only carbon chain. So carbon chain and the functional group you have taken. So you have 2 carbon chain, 1, 2. So the parent is going to be eth. Now what about the substituent? Whatever remains after the identification of puff is the substituent. So this is methyl group and this is ethyl group. So we have methyl, 1 substituent, and we have ethyl, 1 substituent. Now let us number the substituent. When you see the substituent, these are substituents which are not connected directly to the main chain. ना ये first carbon पे, ना ये second carbon पे. तो कहाँ पे ये? They are attached to nitrogen. Okay. If they are attached to nitrogen, then we'll just write N here and N here. What does this N signifies? N signifies that कि भाई carbon chain में नहीं है, nitrogen के साथ ये groups लगे. Okay. So these groups are at what? These groups are attached at the nitrogen. So what will be the name of this molecule? The name of this molecule will be now, see, ethyl and methyl में ethyl will be first because it will be alphabetical order. So N-ethyl. एक काम करते हैं, इसको type कर देते हैं because if I write it down, this will be very clumsy here. N-ethyl, N-methyl, ethanol. ठीक है? Just use the size. Okay, so this is the name. N-ethyl, N-methyl, ethanol. अच्छा, ETHH हो गया, ethane, ठीक है? उसी तरह से इसका नाम क्या हो जाएगा? This also has this parent carbon chain. This will be the amine, and this will be N-methyl ethanol. ठीक है, ये क्या हो जाएगा? N-methyl ethanol. Okay, so I hope you can now name these type of compounds. Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
आपके पास सब्स्टिट्यूटेड अमाइड्स होता है ना, उसमें वही होता है CH3, C डबल बॉन्ड O, नाइट्रोजन है और यहाँ पे आपके पास मान लीजिए लगा हुआ है एक हाइड्रोजन एंड हियर यू हैव CH3. तो ये तो आपके पास क्या हो गया? दिस इज इथेन अमाइड है ना, इथेन अमाइड, और एक सब्स्टिट्यूट है आपके पास क्या? मिथाइल ग्रुप. सो इट विल बी N मिथाइल इथेनामाइड, N मिथाइल इथेनामाइड. लिख लिया आप लोगों ने? लिखिए या लिख रहे हैं जी? डन.
Yes.
Right. Next one, the third reaction, acylation. Now, in acylation can be done with acid chloride, ester, or anhydride. ठीक है, तीनों के साथ किया जा सकता है, but the process is same. You have here I am taking 1 degree amine like this. It will have 2 hydrogens. ठीक है, and C डबल बॉन्ड O एंड Cl यहाँ पे, ठीक है, Cl यहाँ पे। अब ये HCl यहाँ से निकल जाएगा। ओके, बेसिकली ये ऐसे HCl नहीं निकलता इतनी आसानी से। ये सबसे पहले यहाँ पे देखिए, नाइट्रोजन जो है ऑब्वियसली अटैक करेगा यहाँ कार्बोनिल कार्बन पे, ये ऑक्सीजन यहाँ से निकलेगा, नाइट्रोजन और इसके बीच में एक बॉन्ड बनेगा, ठीक है। फिर वापस से ऑक्सीजन अपने इलेक्ट्रॉन देगा और क्लोरीन एज अ लीविंग ग्रुप निकल जाएगा, ठीक है, क्लोरीन एज अ लीविंग ग्रुप निकलेगा एंड साथ साथ वो क्या लेके निकलेगा, हाइड्रोजन को भी लेके। सो सी, फर्स्ट ऑफ ऑल दिस नाइट्रोजन atom is going to attack on this carbon atom, and then we are going to get, as soon as it will attack it, this bond will break and you will get O negative. Here you are going to get nitrogen. This is Cl, this is CH3. This nitrogen, it has 2 carbon and also, sorry, I mean a chain of 2 carbons and 2 hydrogens like this. This nitrogen will get a positive charge because it donated the electron. Okay, so nitrogen का bond carbon के साथ बन गया, carbon oxygen का bond वहां पे टूट गया because carbon 5 bond नहीं बना सकता, nitrogen के पास positive because it has now 4 bonds. Now further what is going to happen, because this hydrogen is going to be very, ये क्लोरीन यहाँ से ऐसे देखिए, ये हाइड्रोजन इलेक्ट्रॉन देगा इसको, क्योंकि क्लोरीन इलेक्ट्रॉन देगा इसको, क्लोरीन इलेक्ट्रॉन देगा इसको, हाइड्रोजन इलेक्ट्रॉन देगा इसको, और साथ साथ क्लोरीन क्या करेगा, यहाँ से बॉन्ड तोड़ेगा और ये ऑक्सीजन यहाँ से निकल जाएगा, ठीक है। ऑल ऑफ दीज थिंग्स हैपन, बट एसेंशियली आपको पास प्रोडक्ट क्या मिलता है, आप ये ध्यान रखिए चलिए कि HCl निकल जाता है, और जब HCl अगर निकल जाएगा, so you will have 1 carbon 2 carbon nitrogen, then you will have this direct nitrogen attached to carbonyl carbon, and then you will have CH3, ठीक है, and then you will have a Cl3. So what is this now? This is, यहाँ पे अगर आप देखिएगा फंक्शनल ग्रुप क्या है आपके पास, CON, अच्छा एक हाइड्रोजन रहेगा यहाँ पे NH के पास, ठीक है, CON, C डबल बॉन्ड O N है, that means it is going to be what, amide. C डबल बॉन्ड O N हो गया, that means it is going to be amide. Unsaturation obviously AN. Then what you are going to have, parent, parent में the carbonyl carbon वाला, तो ये CH, ये दोनों 1 and 2, so it is going to be Eth, है ना, फंक्शनल ग्रुप होना जरूरी है। सब्स्टिट्यूएंट आपके पास ये, दिस इज इथाइल, कहाँ लगा हुआ है, नाइट्रोजन पे लगा हुआ है, तो इथाइल, द नेम विल बी N ethyl ethanamide. Okay, please write here aromatic and aliphatic 1 डिग्री एंड 2 डिग्री, यानी हाइड्रोजन होना मांगता है, ठीक है ना, हाइड्रोजन होना जरूरी है, हाइड्रोजन नहीं है तो HCl नहीं बनेगा, दैट इज व्हाई हाइड्रोजन इज रिमेन इंपॉर्टेंट। फॉर द हाइड्रोजन टू बी प्रेजेंट यू कैन नॉट हैव 3 डिग्री, 3 डिग्री में हाइड्रोजन नहीं होता, ओके। सो aliphatic and aromatic 1 डिग्री एंड 2 डिग्री amines reacts with, किसके साथ रिएक्ट कर सकता है, एसिड क्लोराइड, it can also react with anhydride, it can also react with esters, ठीक है, ये एनहाइड्राइड वाला इंपॉर्टेंट है, इसको हम लोग देखेंगे जब हम लोग इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन करेंगे, ठीक है। सो दिस एनहाइड्राइड रिएक्शन वी विल सी देयर आल्सो। देखिए अभी तक हमें इसमें देखिए एसिड क्लोराइड C डबल बॉन्ड O Cl, एनहाइड्राइड विल बी C डबल बॉन्ड O O C डबल बॉन्ड O, ठीक है ना, CH3, एंड ईस्टर विल बी C डबल बॉन्ड O and R. So we have seen all the C double bond O in something except C double bond OH, carboxylic acid के अलावा। So please write for carboxylic acid क्या reaction होगा? If you have C double bond O and then OH plus NH2 that is attached with R, this lone pair electron. So this lone pair electron will attack on the hydrogen atom and it will give you a salt R, C double bond O, O negative, and NH3 positive, which is attached to R group. Okay, so it gives a salt with carboxylic acid. Please write this down. Guys, done everyone? Let me know once you're done.